For not wearing your mask?
Yeah, I pulled it out for like a second. She's like, I'm gonna give you a second.
Okay. I like have a funny feeling about this. I feel like it's not actually working. Can you hear me? Can you hear me? Can you hear me? Can you hear me? Hello, hello. Okay, good. We're in business. Okay, virtual learners. Hey, y'all be quiet so I can talk to my virtual people. Virtual learners, this is your bell ringer. I'm sorry I forgot to start the video, but these are the answers to the bell ringer. So if you are watching this, you can press pause and go and work these problems. You have to use this formula, and then you're comparing AB to CD. So do your slopes and then compare them, and then the answers are there. So press pause, do that. Okay, now for us in class, we are going straight to check last night's homework. Okay, so everybody had different homeworks. You guys had the evens, so check 2 and 4 quickly. 2 and 4 and 6. Did I go too fast? Okay, check 6 and 4, and I'll go back to 2. 6 is 41, that's right. Okay, then here's 2. What do you mean? Let's see what it actually is. The square root of 528. So it's 22.97. So that does actually round up to be 23. Yeah, no. Okay, and then other side over here, 8 is 12.8. 10 is there for you. 12 is 11. And then everybody did the bottom. So to make this clear, this is a rectangle, a square, all of them. All right, are there any of them that we need to go over? Y'all have questions on? 15 says, which quadrilateral always... Well, that was mean. Yeah. Their diagonals are not congruent. Parallelograms are not, and neither are the rhombus, because they've been like short. 13, right? Any other questions? Number 6. 6 is 4. Okay. Then so to make each other, go back in. Subtract. Everybody's good with the homework? If not, always back and look at that on the video. I will post the module. Today we are working on coordinates. So kind of funny that's what our bell is on. So see today what is it able to which one it is. So I'll add a where check of okay check of diagonal. If then you gotta either not be parallel one. The case is parallel. Case 2 opposite argument a diagonal. That's a rectangle. 4 congruent not congruent rhombus. 4 all circuit argument. It's going to be square. So these ones down, you get this, your situation, all the same, okay? When that is or here, all well, on the side, you have this is go message on what where. So here give these the qualification. So is it a bell angle? Is it a round? Now to determine if it is going to be what is it? We have the length of the side of pairs. Yeah, this formula, if you don't remember here, is for equal root and these squared plus 2 minus a squared. You don't just memorize that. Memorize because you're a man perfect. We're going to do this. We're going to do this form. And while it's a virtual, you will see it because you're still a little. Yeah, I mean, it's going to be some type of quadrilateral. So I'm going to draw it as if it was a rectangle, even though it may not be. Then you say A, B, C, D. So then you have a little idea of who you're comparing, even if it's a square or a parallelogram. This would kind of give you an idea. Okay, so I'm going to start with side AB. We have to do the distance formula. So the distance formula for AB is x2, which I'm going to let 8 be my x2. So B, and I'm going to go backwards. So I'm going to have 8 minus 9 squared. Those are my x's. Then I have y's. Negative 2 minus negative 4 minus a negative is the same thing as plus squared. Okay, so what is 8 minus 9? So that's going to be negative 1 squared plus what's negative 2 plus 4? That's 2 squared. So what is negative 1 squared? 1 plus what 2 squared? 4. So 1 plus 4 is. So I'm going to leave it just like that because I can compare these square roots. So if somebody else has square root of 5, I'll ruin. Okay, I don't need a decimal. I can just leave it like that. Okay, C. The distance formula for CD, I'm going to go from D back to C. So that's going to be 3 minus 2 squared plus negative 7 minus negative 5 squared. And I'm going quickly because this lesson is not on distance formula. You hopefully already know this. This is 1 squared. 1 squared is 1. This is going to be negative 2. Negative 2 is 4. So that equals the square root of 5. So far we've got two sides of the same. That would be AB and CD. So we at least have a rectangle or a parallelogram. Okay? So then now we are going to go back and do BC. So I'm going to do the top. And I'm going to go from C back to B. So this is formula. I'm going to go C, which is 2 minus 8 squared, plus negative 5 minus negative 2 squared. So it's going to be negative 6 squared, which is 36. This is going to be negative 3 squared, which is 9. So 36 plus 9 equals 45. So we don't have a square or a rhombus. But if the bottom AD is 45, then we have either case 1 or case 2. All right. So now I'm going to do D minus A. So that's going to be 3 minus 9 squared plus 7 minus negative 4 squared. 3 minus 9, negative 6. Negative squared, 36. Negative 7 minus 4 is negative 3. Negative squared is 9. So what do you know? It's 5. So that means we either have case 1 or 2. We either have a parallelogram or we have a rectangle. Now, how are we going to determine which? We know if it's case 1 versus case 2. The diagonals. We need our diagonals congruent or congruent. Okay, so I'm going to start with AC. All right, so AC, I've got a distance formula for A. I'm going to do C minus A. So I've got square root of 2 minus 9 squared plus negative 5 minus negative 4. So that is what's that? Negative squared, which is 49. This is going to be negative 1 squared, which is 1. So together, that gives me 50. Square root of 50. The AC, that's the diagonal. AC is the square root of 50. Now I'm going to do BD. Oops, not B, BD. Distance formula equals B minus B. So 3 minus 8 squared plus negative 7 minus negative 3 minus 8 is negative 5 squared, which is 25. And then 7 minus 2 is negative 5. Negative 5 squared is 25. Together they are the square root of 50. So what do we know about our diagonals? They're congruent. So we've sets of sides that are congruent, and we've got diagonals that are congruent. So what do we have? It's a rectangle. Now, that's a lot of work just to get that. Okay? So I am going to show you these, and we're just going to discuss these. You don't have to write this down. Just look at my notes. So this is number 2. Okay. So if we look at number 2, we've got all of our 4 sides, the distance formula, and what do you know? It's a square or a rhombus because everything was 13, right? Okay. So then still have to determine if it's going to be a square or a rhombus on the diagonals. So here's our diagonals. Okay. They're diagonals. This one's 36. This one's a 16. That one's 6. That one's 4. So that means they're not congruent. Since not congruent, it's rhombus. Sense? Okay. Let's look at number 3. Number 3. They did this one for all 4 sides. Okay. 18, 73. So they're not all the same, which means it's either a rectangle or a parallelogram. Then they did the diagonals. Those 2 are not the same, which means it is a parallelogram. This is how it is supposed to be. Okay, cool. All right, so you got that. Now there's some examples on the back. So again, going to show these to you. So look at number 4. Okay, we look at number 4. They did sides. Everybody's 26. So you're a rhombus or the square. They did diagonals. Those are both squared before. I'm sorry, for 2. So it's a square. Last one. They did all the sides. 13, 13, 73, 73. Not all the same. So it's a rectangle or a parallelogram. They did these. Not the same. Parallelogram. Everybody understand? It's looking at the distance formula, it ain't no big deal. So now let's get to the last little page. And it is wanting us to do a little bit of work with this. So quadrilaterals in the plane. It's on well, let's read the directions. Use your knowledge of slope, distance, midpoint, and properties of quadrilaterals to answer the following questions. These are the kind of questions that you'll see on the ACT. This is the kind of stuff that you will see. It's not going to be something like plain simple like this, okay? I mean, maybe, but probably not. Usually, it's like missing information or gives you some information and wants you to find whatever is, not given. So let's look at number 1. It says, on a parallelogram PQRS below, if P is located at -1, 6, so this is at -1, 6, and S is located at -7, -3. Okay, what is the slope of QR? Well, what do you know about QR's relationship with PS? They're parallel. So since we know they're parallel, what do we need to do with these ordered pairs? We need to find the slope. You find the slope doing y minus 1 all over x2 minus x1. So I'll let the one bottom be the 2's. So y2 is going to be -3 minus 6. Y1, no. x2 is going to be -7 minus -1. So plus 1. Basic slope, you probably did this in middle school. -3 minus 6 is -9. -7 plus 1 is -6. That simplifies to give us what? 3/2. Our slope is going to be the same because it's going to be parallel. So you leave it just like that. Make sense? Now, it says on rectangle. So this is a rectangle. A, B, C, D below. A is located at 3, 4. And B is located at 7, 6. What is the slope of BC? Now, what do you know about the relationship between AB, the segment AB, and segment BC? How do you know they're perpendicular? They make a 90-degree angle because rectangles have 90-degree angles. So since this is a 90-degree angle, those 2 sides are going to be perpendicular. So we find the slope. I'm going to do that quickly. 6 minus 4, 7 minus 3. That's 2/4 with 1/2. Okay, did I do that right? Okay, so the slope is 1/2. So we're looking for the perpendicular side of BC. So what do we need to do to find that? Opposite reciprocal, which is going to be -2/1. Which is just -2. Everybody okay? Number 3, on the rhombus WXYZ, if W is located at -5, -2, okay, and Y is located at 3, -2, what is the slope of XZ? Again, what do you know about Y, DU, and X, Z. The rhombus. They're perpendicular. The diagonals are perpendicular for a rhombus. So again, number 1, find slope. Number 2, perpendicular. And that's what I'm going to leave it as. Number 4, on the square, we're dealing with a square. If J is located at -2, +5, and K is located at 2, 2, what is the slope of LK? What's the relationship between AK and LK? Well, the distances are congruent. You're looking for the slopes. They 90 degrees. Also, they are perpendicular. Same thing. Find the slope. Number 2. And I'll show you the answers in just a second if you are working faster than me. Number 5. Number 5 says on parallelogram STUV below, if S is located at -4, -1, so S, -4, +1, sorry, -4, +1, and T is located at 5, 3. What is the length of VU down here? What's the relationship between ST and VU? They're congruent. So how are we going to find the length of ST? We love the distance formula today. So I'm going to do this quickly. -4 - 5 squared plus 1 - 3 squared. That's going to be -9 squared, which is 81. That's going to be -2 squared, which is 4. So that's the square root of 85. You could then give me a decimal for that. The square root of 85 is 9.2. 9.2. So that means U is 9.2. Because they're the same. Okay, number 6, square. We're dealing with a square. Below, Q is located at 7, 0. R is located at 5, -8. Okay, what is the length of SR? What's the relationship between our sides? They do make a 90-degree angle, but we're looking for the length. They're the same. Okay, so you just need to find the distance. And then number 2, answer is the same. Okay, number 7. Number 7 down there. Okay, it says on rectangle DEFG below, DE is located, or just D is located at -1, -1. And F is located at 4, 8, for -8. What is the length of GE? What's the relationship between the diagonals on a rectangle? They're congruent. So what do we need to do? What are our steps? Find distance, and then what? Same. Okay, number 8. One more. Parallelogram. If A is at 1, 1, B is 8, 8, 5, C is there, D is there, what are the coordinates of E? What are we going to do to find that? The midpoint formula. Okay, so I would take AC possibly and do your midpoint formula for AC, and that's going to give you that. Midpoint formula is x plus x divided by 2, y plus y divided by 2, and that's going to give you that ordered pair. Now, I have a homework sheet for you. Oh, almost smoked that thing. You guys are doing number 2 and 4. That's it. Actually, you know what? Just do number 2. I mean, it's Christmas. Just do number 2. I didn't punch holes in it. Sorry. Yep, that's what I said. Just number 2. This is where you say, Miss Cole, we love you. Oh my God, you're the best. Y'all have to like boost our, boost our self-esteem. That's your job as a student. Yep. Skylar. Freaking rude. We have a participant. Who's with us? Jalen, hey.
Hi.
How are you?
Good. How about you?
I'm good. I'm going to end this. Do you have any questions?
I know I'm good.
Okay, cool. I'm going to post the video, so if you need to watch back at anything you can, okay?
All
All
right.
right. Have a good day.
You too.